Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the electronic nature of substituents for each compound. JEE C6H5NMe2. NMe2 is a powerful electron-donating group, EDG, via resonance plus M effect, strongly activates the ring toward electrophilic aromatic substitution, EAs. A. C6H5CH3, toluene. CH3 is a weak EDG via hyperconjugation induction activates the ring moderately. B. C6H6, benzene, unsubstituted reference compound. C. C6D6, deuterobenzene. D is slightly more electron-donating than H due to a smaller primary kinetic isotope effect and slightly stronger C-D bond, inductive, but the ring electronic activation is essentially the same as benzene. However, because the C-D bond is stronger than CH, the rate-determining step, proton-deuteron loss, is slightly slower for C6D6 than C6H6, making C slightly slower than B. D. C6D6, tritiobenzene, T, tritium, has an even stronger kinetic isotope effect than D, making C-T bond even stronger, so rate of C6D6 rate of C6D6. Thus DCE, C6H5Br3, Br is a weak deactivator, I inductive effect dominates over weak plus M, deactivates the ring, so rate benzene. F. C6H5N plus R3, the quaternary ammonium group, N plus R3, is a strong electron-withdrawing group, EWG, via both I and M effects, strongly deactivates the ring. This gives the lowest rate among all. Moving on to the next step. Establish the order. G. Strong EDG, NMe2, A. Weak EDG, CH3, B. Benzene, reference, C. C6D6, kinetic isotope slows slightly, D. C6D6, kinetic isotope slows more, E. Weak EWG, Br, F. Strong EWG, N plus R3. Moving on to the next step. Match with options. Option A. G, A, B, C, D, E, F. This matches the reasoning above perfectly. Option C, G, A, B is equal to C is equal to D, E, F. This would mean benzene, deuterobenzene, and tritiobenzene all react at the same rate, ignoring the kinetic isotope effect. Option D, G, A, B, C is equal to D, E, F. This would mean C6D6 and C6D6 react at the same rate, ignoring the difference in isotope effect between D and T. Option B, G, B, C, D, A, F places toluene after isotope substituted benzenes, which is incorrect. However, the given answer is C, G, A, B is equal to C is equal to D, E, F. The reasoning for option C being correct is that for EAS, the rate-determining step is the attack of the electrophile, formation of the arenium ion sigma complex, not the deprotonation step. Since the kinetic isotope effect only matters if CH-DT bond breaking is rate-determining, and in EAS the rate-determining step is electrophilic attack, not the elimination of H plus D plus T plus, benzene, deuterobenzene, and tritiobenzene all have essentially the same rate of nitration. The electronic effect of D versus H on ring activation is negligible. Therefore, B is equal to C is equal to D in rate of nitration. And for the final step, GAB is equal to C is equal to DEF, which is option C. Therefore, the correct answer is C. Therefore, the correct answer is option C.